Hi, this is Matthew, Wiley, and this is the fluids quiz. I'm gonna show you my the work I did. Let me just pull up the file, the PDF. It's the wrong folder. Hold on. Okay. So in this problem, we have a constant height of the water H in a bottle, and somewhere below H at a height little h, a little hole is poked through and the water is released perfectly horizontal, and we have to find out what is the max distance from the edge of the bottle. And to find this, the first thing we need to do is get the velocity of the water as it's moving out of the hole. So for that, we use Bernoulli's equation. We take 2 points. One of the points would be up here at the top of the water and one right by the exit, because these both are the atmospheric pressure, so they would get canceled out. And when we plug all of the information in, we have the pressure up here and its velocity term and the height term, and then we have the pressure here and its velocity and height term. And we want the height from the bottom, so it's the big H minus the little h. And we know that for both of these points, the pressure is atmospheric, and we can assume up here at the top that the velocity is 0, because this diameter is much more bigger than the one down here, so it's almost like it's not moving as the water decreases. So when you plug in these two, you can cancel out the pressures, and it leaves you with the height term of the first point here, and you have the velocity term of the second point with its height term. And if we solve out for its velocity, you just start canceling things out, and this term becomes rho g, and then the rho's cancel out, and then you get root 2 gh as the velocity as the water leaves the hole. And now the only thing else we need to find is the time, and since we know the water is leaving perfectly horizontal, we can use the time it would take for the water exiting here to hit the ground. So we take the height h minus little h, this height, and find how long it will take to reach the ground using this gravity term. And there's no other velocities occurring in the vertical direction, so it is just this. And solving for time, you get 2 h minus h over g square root. And now with the time and the velocity, you know that to find the distance it travels from the bottom, you just multiply velocity by time, because in the horizontal direction there's no acceleration happening to it, so it's just velocity times time. And we take the two terms we had before, we get this distance, and since we need to find the maximum distance depending on the little h term, we have to take the derivative of this and set it equal to 0, which would find the maximum. So we take the derivative of this, of the distance term in terms of the little h, and we end up with this formula here, and we can multiply out this bottom term, and then when you solve for little h here, you end up with big H over 2, So the maximum the water will travel coming out of the bottle would be when this H is half of this, so somewhere in the middle. And now I'm going to have Max show you the tests he did.
Okay, for this one, again, 8 inches. The hole height is 3 inches. Measure straight out. Fill it up to the top. Gives us about 8. From the bottom to the top, it is about 8 inches, and the hole height is 4 inches. So we're gonna fill it to the top, and the hole height should be H/2. Okay, and we're reading about 5.5 inches. Okay, so I've tried some more holes, and I'm pretty sure that it wasn't going as far because the bottle is like angled down. So I tried poking a hole with a little bit of like a angle to it, I guess, to try to balance out the curvature of the bottle. So once again, bottle height is 8 inches. Tried a couple holes. Hole height is at 4. Roller straight out. Bottle up to the top. And it's about 7 inches now. For the 5-inch one, top is 8 inches. The hole is 5 inches. We're getting about 7.5, or more like 7. We fill it up, top is 8 inches.